Hello. Why is understanding size and scale so important? Let's take a look at a couple statements, and maybe this will help us understand why it's important. Consider the following statements. When the police officer arrived at the scene, she noticed that the victim, John Doe, had suffered a gunshot wound to his left arm. Think about if you were the police officer and you arrived at a crime scene or a situation in which somebody was in danger. You'd be able to assess that situation and you'd be able to make a pretty good have a pretty good idea of how to handle it. Consider the next statement. Clotting factors such as prothrombin are converted into more complex materials that are utilized to clot blood and prevent blood loss. Is this statement the same? No, it's completely different. Are they related? Possibly, but in a lot of ways, they're very much different. One is at a different scale, and one could be at a larger scale than the other. And with this, you have to have an understanding of what the person is talking about. So it's important to have an understanding of size and scale so you can communicate with other people about certain phenomenon. Let's look at some pictures. It might be a little bit easier. Take a look at the picture that's shown here. Why is scale important? Cause and effect situations and the phenomenon that are related to these are often situations in which we have to use size and scale to explain. In this picture here, it appears as though there's some kind of deforestation that's occurring. We see some land that's being utilized maybe for mining or who knows for that matter, but we notice that there's a lot of trees that have been lost in this situation. So we have some sort of cause, human interaction, and then effect, deforestation. And by understanding what scale we're at, we have a pretty good idea of what's going on. Well, what scale would it be at? Well, we have 4 scales that we examine in biology. We have large scale, macroscopic, microscopic, and atomic molecular. What size do you think this one would be at in terms of this picture here? Take a minute and think about it for a second. What do you think it is? Did you say large scale? Well, you are correct. This is definitely a large scale picture. We can see a pretty good size amount of an ecosystem here and some other things, and it tells us that we're at a pretty large scale. So very good if you guess that one. All right, let's go to the next one. Here we have a picture of SARS-CoV, the virus itself, and also it shows some different things that it's capable of doing. Take a minute. What do you think this picture is? Do you think this picture is large scale, macroscopic, microscopic, or atomic molecular? This one might be a little bit tougher. If you guessed atomic molecular, you are definitely in the right area, and it would be a good possible answer for the situation here. These are fairly large molecules, these phospholipid heads and tails that make up a cell membrane, and we have these receptors here. It doesn't necessarily show the atoms that are involved, but it is something to that effect as well. The other thing it could be possibly is something that's very, very microscopic. This would have to be almost at using an electron microscope. I would probably say it's probably more at this level, but you're not totally wrong if you guess the atomic molecular either. The more you practice you get with this, the better you'll get. Let's look at these scales a little bit closer. So what we have here is we have our large scale, which has a representation of 10 to the third meters or 1,000 meters, or what is known as a kilometer. And it goes all the way up pretty high here. So we get into even the thousands of kilometers and so forth. And we can go all the way down to the atomic molecular scale, which is this nanometer down here, which is 10 to the negative 9, which is super extremely small, which is, we're looking at atoms and things like that. If we look at the next slide, it's going to give us some examples to help us understand this a little bit better. For large scale, You can see here, we see almost like some cities and towns and roads and so forth. And we see like the upper peninsula and the upper northern peninsula of our state. And we see even a picture here of our Earth. So when you look at the video that is part of your assignment for this, which is the Powers of 10 video, you'll see some of these powers of 10 and how they are associated with an image that you can see over here and tie that together for what scale you're at. The scale that you're probably most familiar with is the macroscopic scale. This one is the most common thing because this is what we are kind of our surroundings when we're dealing with things like this. Everyday stuff. Here is our ethanol, for example, that we just looked at. That's a macroscopic situation. So the macroscopic scale is probably the most common. And is the easiest one for us to recognize. So we can see here the ethanol, plants around us, animals, you have pets at home, things like that. That's all at the macroscopic level. The macroscopic level ranges from meters to millimeters, things that are simple to measure using the tools that you have around you. Some of us, if you've been in previous classes or had the opportunity in science classes to use a microscope, you may have looked at things at the cellular level. And you can see here we have a picture of it looks like some type of plant cell in both of these examples here. So when you're dealing with these things, you're going to get possibly down into the micrometers or micrometers, which are very small and is 10 to the -6 level. So there again, these are your levels, and this gives you an idea on how you can examine things at the different levels. Again, you'll get more practice with this in the activities. Your task is to complete the Powers of 10 Google document. And if you get an opportunity in your bill, you want to answer the conclusion question, which is why do scientists consider things at multiple scales? And make a prediction of what molecules you would expect to find in a box of air. You should discuss these two things possibly with your bro or your sis. So your brother or sister or somebody at home, feel free to ask them if they would even know what some of these levels are. You could even practice on them. But in the meantime, complete the Powers of 10 Google document. Make sure you watch the video that comes from 1977, pretty old, and it's got some strange music to it, but it's kind of cool in how they made it. And then you'll get some practice by putting different pictures into the different levels on that document. Good luck. Thank you.